Hi there, welcome to this tutorial on collection interface. What we look at in this tutorial is first we would start off with why a collection is needed, why not arrays, and then we look at the important methods in a collection interface. A lot of people dive into things like array list or a hash map and dive into the interfaces of maps or lists. But I think it's very important to understand the basic interface. I mean, it's basically the super class interface. I mean, super interface for all the other stuff. So it's very important to understand the collection interface in good detail. Then whatever is in the collection interface is definitely offered by all the other stuff. So we can learn the other stuff as collection interface plus something else. So yeah, there we go. So let's get started. We'll start off with the first thing. I mean, what does a collection do which an array cannot do? I mean, what is the reason why you would need to go for a collection or not just be satisfied with an array? The first reason is very simple. Arrays are immutable. What that means is once an array is defined, you cannot add elements into an array or remove elements from an array. Nothing of that kind is possible. If you want to really add an element into an array, what you need to do is create a new array of size 1 bigger and put the element somewhere inside that. Or if you want to delete an element from the array, you should create a smaller array, and yeah, you know what I talk about. So yeah, that's one of the main reasons. The other reasons are arrays are not really thread safe. So multiple threads, synchronization and all that kind of stuff would be a big trouble with arrays. And yeah, arrays can contain null elements. You can't prevent an array from having null elements, whereas you can prevent collections from having null elements. There are n number of reasons, like the list goes on and on and on. So those are the important reasons why you should not be satisfied with an array and you should prefer an collection for most of the scenarios. Okay, by the way, what a collection means. A collection is a group of objects of same type. So that's the reason why you'd see when I see the interface collection, it would be defined on something of this kind. So I can open the collection interface just for us to take a look, but it would be a huge list of methods. So if you look at how Java defines the collection interface, this is what it is. So it's a public abstract interface. So collection, this is a collection of type E. So you can store any objects of this type inside this collection. So collection is basically a list of objects, and like the basic collection interface supports all the methods which are present in here. So I've basically replicated those methods in here, but in a proper order. So let's look at what are the different things that you can do on any class which implements the collection interface. There are a number of classes which implement the collection interface, like the array list. I mean, anything that ends with a list, anything that ends with a set, anything that ends with a queue, all of them implement the collection interface. So what does that mean? That means all these methods which we are talking about now would be part of those classes as well. So they would implement these methods as well. So what are the different things in this collection interface? Basically, collection is a set of objects. That's basically what it is. And all the methods which collection contains are methods either to add an object, to delete an object, to check whether an object is present in there, to check whether what's the size of a list, whether it's empty. All those kind of things are possible in an collection. So let's get started with basically the first method in a collection. You have a bool method add. So you can add an object to a collection. You can either remove an object to a collection. You can use the contains all method. The contains all method helps us to identify if, let's say, I have a set of objects and I would want to check whether all these objects are present already in the collection. So that's the contains all. So if I call it with a set of objects, it would return a true if all those objects are present already inside the collection. And also you can add not just one value into the collection, but you can add multiple objects into the collection. So if I have already an existing collection which is let's say a set of 5 objects, and I would want it to add to another collection which already has 15, I can do that as well. That's the add all method. You can also remove all. Basically you are saying, you are giving a list of objects and you're saying remove all these objects from the collection. And also retain all is another important thing. Basically what it does is, let's say I have a set of objects and I call retain, I've set a collection with 10 objects and I'm calling a retain all on it with a set of objects, then it would retain only those elements that are present in the collection. So let's say if I have A, B and C in the collection, and I'm saying retain B and C, so only elements B and C would be retained. So that's the retain all method. And the other method is clear. You want to empty everything in the collection. That's your method, clear. And yeah, equals method, obviously you want to check whether this collection is equals with some other collection, and when there's an implementation for equals, the implementation for hash goes as well. The other important methods are size of an array, is empty, whether it's has any elements or not, and also whether you can check whether if it contains an object or not. And all like as you can see, the collection interface extends the iterable interface. So you have the iterator also. So you can use the iterator to go around all the objects inside a collection. And the other important method is toArray. So on a collection, you can call it on any collection, whether it's a list, whether it's a set, or whether it's a queue. On all these collections, you can actually call toArray, and you would get the objects in an array format. So what we are looking at right now is to just get a high level overview of this collection interface. We will really look at all the implementation. We will later take the ArrayList class and show how all these methods work really on an ArrayList class, and probably also on a set and other stuff as well. But this is just to get an overview, a high level overview of the collection interface. So this collection interface is a very important thing. In the next video, let's look at all the stuff related to the sub interfaces of collection, like list, or also the set interfaces, and also the queue interface. If you like this video, show it by clicking like or commenting or sharing this video. We are creating more videos on varied range of topics as we speak. Subscribe to stay updated. Thanks for watching. Until next time, bye. Hi there. Welcome to this tutorial in Java, where we learn about the overview of the collection framework. So what we'll look at is all the different frameworks which are present in all the different classes which are present in collection framework. What are the different maps which are present? So you would get a complete overview from the high level of what the collection framework is. So let's get started quickly. What is the collection framework? Collection framework is used to store a group of items. So I have like different batsmen who are present. So Sachin, Lara, Ponting. So I want to put them in a single group. So I use some kind of a collection, and which kind of a group you put them in depends on what you want to do with those batsmen. So let's look at the different collection things which are present. So the collection, the first interface which is present in Java collections hierarchy is collection. The collection defines, this interface which is collection defines the various methods which any collection in Java should offer. So what are the different methods? The first one is size. You can find out how big the size of a collection is. If you look at any collection, it offers methods to add, remove, to check if a particular element is present, to check if the collection is empty method. You can remove a list of items. You can retain a list of items. That is basically, I have a list of 5 items. I only want to retain 2 among them if they are present. So I can say retain this and this. So if you look at these, and also equals and hash code. The equals and hash code are kind of the basic methods which are present in all objects. So, and also you can make a collection as empty. So these are the basic methods which are present in any collection in Java. So you look at any collection in Java, these methods would always be present, and that's why this is the basic interface, the base interface in collection hierarchy. So the base interface defines methods to add an element, remove an element, find the size, make the list make the collection empty, to check if a particular element is present. You can check if a list of particular elements are present, and those kind of stuff. If you go a little bit below, the next collection, which is the next interface which is important in collections, is set interface. The set interface is really basically an extension of the collection interface. There is no new method which is put in the collection interface for set, but the most important thing is all classes which extend set interface only allow unique elements. So I cannot have the same element twice in a set. So that's the most important distinction between a set interface and a collection interface. I mean, the difference is basically in the usage and not really in the definition of the set interface. So the set interface extends the collection. So set is basically a collection, but all the things which extend set store unique elements. You cannot store duplicate elements in the set. The next one the next interface which is really important is the list interface. The list interface also extends the collection interface, but the most important thing is a list. In a list, the position of the element is important. So list is a collection where the position is important. So it really is important whether the, like for example, in the order of runs, if you look at it, Sachin is at position index 0. That's very important. It is not fine if Sachin is at 4, for example. So in these kind of things where position is important, we have the list interface. If you look at the list interface, the methods which it offers, they'll all be related to adding, like these are in addition to the collection interface. The list interface extends collection interface and provides methods which deal with an index. So you can get an element at an index. So I can say get of 1. So that would return me pointing. You can say set an element, set at 5 a value. So it will push all the other elements further down and will insert that particular element. You can add an element at a particular value. Or sorry, set would not push the things, but it would just make the value change. Add would really add it. Remove the element. So I can say remove 1. So pointing would be removed from the list. And you can also find the index of. So I can find, give me where Lara is present in the list. It returns back 2. You can find the last index of. So this also says the thing that in a list, elements can be duplicated. So last index of means if Lara is present twice in this list, it would give the last index of Lara. And you have a couple of iterators. So these are the important methods in the list interface in Java. So if you look at the other interface is queue interface. If you look at queue, it also extends collection interface, but the thing about the queue is all the elements are ordered in the way it's inserted. So if I've inserted 1, 2, 3, 4 and then 5, then they are also stored in that order. The elements which methods which queue interface offers are more add, and offer is to take out, and like offer, then you have remove is to remove an element from the queue. Poll is just find out what is the last element, but it doesn't really remove the element from the thing. And also you can get the different things. So that's the queue interface. There are different types of queue as well. The most important other interface is map. The most important thing that you need to notice is the map interface does not extend collection interface. So all the methods which are present in the collection interface are not offered by the map interface. The map interface stores values in a key value pair. So you'd store the values in a key and a value pair. So it's basically a key value pair. So that's where the map interface would be used. So if you look at all the methods in the map interface, they will be directed at that. So they'll be directed in finding out does it contains this particular key, does it contain this particular value, or put this key and this value, or get the value present for that particular key, remove a particular value. So remove based on the key. So the map interface defines things based on the key and value pair. So you can have a lot of key and value pairs, and also for that particular key you can only have one value. So that's basically the concept behind the map interface. So that's a kind of an overview on the collection framework. So that's basically an overview on the various interfaces which are present in the collection frameworks. And we looked at the collection interface, we looked at list interface, we looked at queue interface. List and queue interfaces are extending the collection interface. And at the end, we looked at the map interface, which is not really extending the collection interface, but it provides a way we can access elements using key value pairs. So these are the different interfaces which are present in the collection framework. Until next time, bye.
If you like this video, show it by clicking like or commenting or sharing this video. We are creating more videos on varied range of topics as we speak. Subscribe to stay updated. Thanks for watching. Until next time, bye.
Hi there. Welcome to this Java tutorial where we'll look at the various examples of collections in Java. You can look at the other videos in our channel to understand the hierarchy of Java classes and also understand the different interfaces which are present in collection. In this class, in this video, we'll look at the different classes which are present in the collection interface. So we in the other videos you can detailedly look at the different interfaces which are present in collection and the different methods they offer. So the base interface is collection. Collection contains the different methods to have a list of items. So you can add an element, remove an element, find an element, check whether an element is present in a collection, and all those kind of stuff. Set interface extends the collection interface. The only important thing about the set interface is that it only can contain unique things. So it only can contain things which are unique. So you cannot have the same element present twice. So that's the main difference between a set and a collection. So set and a collection, the main difference is that you cannot have duplicates. The first example class of the set interface that we look at is the hash set. So hash set implements the set interface. The most important thing about the hash set is the elements are unordered and unsorted. So they are not in the insertion. When we say unordered, it means they are not in the order of insertion. So if I insert 1 first and 2 next, when I say unordered, it means they can come out in any order. But if I say ordered, then they will be stored in the order of their insertion. So if I insert first 1 and then 2, then first 1 would be stored and then 2 would be stored. So when we say unordered, then order of insertion doesn't really matter. And when we say unsorted, then that means they are not sorted in any way. So if I insert integers 5 and 2 and 1, then they will be stored in some random order and not in the sorted order 1, 2, 5. So hash set, the most important thing is unordered, unsorted. And also the next class is linked hash set. The main difference between linked hash set and hash set is that in linked hash set, we store it in an ordered way. So it's ordered and unsorted. So set has, and the last one is tree set. So it's sorted. When we say sorted, it means the order of insertion doesn't really matter. They are stored in the order of the value. So if I insert 2 first, 5 next, 7 next, or I'll take a different example. If I insert 7 first, 5 next, 2 next, then 3 next, then the way it would be sorted is 3, 5, 7. So they're stored in the sorted order. In linked hash set, the most important thing is the order of insertion is important. So if you inserted 5 before 3, then 5 would be first and 3 would be next. So those are the 3 classes in the set interface. So hash set, linked set, and tree set. The most important thing is for all these things, all these 3 classes don't allow duplicates. So that's very important. The next thing which we'll look at is the list interface, which offers methods where position is important. So I want to insert a element at position 15. I want to delete the element at position 10, and those kind of things. So if you look at the classes of the list interface, the important ones are array list. Array list is one where the basic implementation of the list. So you can add an element, you can remove an element at a particular position, you can add an list of elements at a particular position, and those kind of stuff. Those are all possible in array list. The vector class is a synchronized thing, so it's thread safe. So if I'm writing a program which needs to be thread safe, then I would definitely not use an array list. So vector is basically an array list which is thread safe. So even if I use it across multiple threads, there will not be a problem. And the last one in here is linked list. So in linked list, like linked list, the most important thing is the insertion and deletion are faster. So when I compare linked list with array list, it's easy to insert and delete from a linked list. So they are however, the thing is, for an array list, the insertion and deletion are slower, slower compared to the linked list. So those are the important example classes of the list interface. And let's now look at the queue. The queue interface is to store elements in the order of their insertion, and it obviously allows duplicates. So the main difference between a linked hash set and like a queue is that queue allows duplicates. So you just insert the elements in the order, and when you take them out, they come back in that particular order. The last interface that we look at is map interface. Map interface offers methods which store in key value pairs. So I can store with the key A, store a value something. So those are the ones which the map interface provides. The important implementations of the map interface are hash map. The most important thing is hash map is unsorted and unordered. So there is no particular order in a hash map. However, hash table is synchronized. So the synchronized version of hash map is hash table. And also you'd see one more difference is hash map allows a key with null value, whereas hash table doesn't. Linked hash map implements a map. However, the most important thing about linked hash map is insertion order. So it's ordered but not sorted. And the tree map is sorted but not ordered. So tree map is sorted. So the way you can remember this is in the implementations of maps, like the first one is hash map. It's not sorted, not ordered. Linked hash map, it's ordered. That order of insertion is important. Tree map is sorted, and the order of insertion is not important. So that's basically all the classes which are present in the collection framework. These are basically the examples. Look up the other tutorials in our channel for more information on all these classes and what you can do with each one of these. Until next time, bye.
If you like this video, show it by clicking like or commenting or sharing this video. We are creating more videos on varied range of topics as we speak. Subscribe to stay updated. Thanks for watching. Until next time, bye.
Hi there. Welcome to this tutorial from rithus.com. In this tutorial, let's look at the list interface. So we'll look at what are the different methods which are present in the list interface, how does it differ from the collections interface, and what are the different things that you need to understand about the list interface. Let's get started. The first thing is the list interface extends the collection interface. So collection is the basic interface that is defined in the collections class, collections in Java. The collection interface offers a lot of methods in Java. So the collection object collection interface has all these methods. So you can check the size of the collection, you can add an element, you can remove an element, you can check if there is an element present. So you can do a contains to check if an element is present in a collection, and a lot of other stuff. So a collection is the basic interface in the collections in Java. But the interface that we are talking about now, which is the list interface, extends the collection interface. That means it provides all the methods. It includes all the methods from the collection interface. So all the methods that we looked at in the collection interface, like add, remove, contains all these methods are also part of the list interface. So the list interface in Java contains all the methods that are present in the collection interface and a few additional methods. So these are all the additional methods which are present in a list interface. The main thing that a list provides is the position. So in a collection, you are generally not in a generic collection, which is not a list. You are not worried about the position of an element in the array. So let's say I have a collection of objects 1, 2, 3, 4. If you're not concerned where 1 is, where 2 is, where 3 is, where 4 is, then you don't need to use a list. But if I'm really concerned that the position should be exact, so let's say I want to order the batsmen in terms of the number of runs they have made. So first would be Sachin, and then probably somewhere down the line would be Lara, and then somewhere down the line for now is Kohli. So in this position, in this list of things, the position is very important. Sachin is at 0, or I'm talking about the index 0, but position 1. Lara is 1 and Kohli is 2. So in this particular example, the position really matters. Sachin is 0, Lara is 1 and Kohli is 2. If you change the order, then the thing is wrong. So in these kind of situation, we use something called list. So list is the interface which is the generic thing for the classes where position is important. So we really care about which position the object is in. So if you look at all the methods in the list interface, they allow you to add elements or remove elements by specifying the position. So if let's say I had this list, then I would be able to do that particular list. So let's say this particular list was batsman's list. The name of this list is batsman. Then I would be able to do batsman dot remove and say which position I want to remove from position 0. I want to remove from position 1. So all these kind of things are possible in a list. So in list, the most important thing is the position is very important. So if you look at the kind of methods which a list interface provides, it says get and a value. So I can say batsman dot get which position I want to get it from position 2. So I would get Kohli back. So I can also say batsman dot set and at a position somebody. So I can say batsman dot set. I want to set him at position 2. I want to probably put somewhere, let's just say Ponting, in between Lara and Kohli. So what happens is Lara will be position 2. So it would be between Sachin and Lara. Ponting comes in. So it would become Ponting, Lara, and the position of Lara becomes 3 and Ponting will become 2. So I will be able to add a element at a particular position. So at this position I want to add this element. I can remove something. So I can say remove 1. So Sachin goes away. Or sorry, I think I got the index a little wrong. So this is the right index. So you can do that, and also you can find the index of a particular thing. So I can say batsman dot index of Ponting, and I would get a value 1. And I can, like, the another thing about a list is list allows for duplicates. So generally all lists allow for duplicates. That's why here you'd see a last index of method. So you are saying, like, Sachin can be twice in this list, and then I want the last index of Sachin. So that kind of stuff. And you have iterators defined on the thing. So basically, if I can summarize the list interface is an extension of the collection interface, and it provides methods which care about the position. So in addition to the normal methods in a collection, list interface provides methods which care about what is present in that particular list of values. Okay, there you go. That's the list interface. Until next time, bye.
If you like this video, show it by clicking like or commenting or sharing this video. We are creating more videos on varied range of topics as we speak. Subscribe to stay updated. Thanks for watching. Until next time, bye.
Hi there. Welcome to this tutorial from ritus.com, where we are looking at the map interface. So we'll look at what's a map, what are the different Java classes which implement the map interface, and high level what are the differences between those classes. Let's get started. So what's this map interface? I mean, what does the map interface define? Map interface is an interface which defines all the methods that would help you store values in a key value pair. So key value pair. So let's say I want to create a list of I want to maintain an inventory of things. I mean, let's say I'm running a car shop, and I want to find out how many cars of each type I have. So one of the implementations that I can consider is to store the values in a key value pair. So for example, I can say I have BMW 3 cars, and I have Mercedes 1 car. Oh, if I have all this, then probably I would be during this tutorial, but yeah, just for an example. And let's say I have another variety of the car of 2 types. So I would put these as key value pairs in the hash map. So I will put BMW as the key and 3 as the value. So when I'm processing the list of cars, as soon as I see a car of Mercedes, I'll say get the key of Mercedes and increment the value by 1. So let's say I have another BMW car, then I would say BMW, 4. So basically, the map interface is used for things which store a key value pair. Here the key is BMW and the value is 4. Mercedes and 2. So if you look at all the methods in the map interface, the first thing that you need to note also is that map interface doesn't extend the collection interface. So even though map is part of the collection discussion, it doesn't really extend the collection interface. So that's a very important distinction. And also if you look at all the important methods in the map interface, one of the most important methods is put. So I can put at a particular key a particular value. So I can remove a particular key and get the value for particular key. So I can say put, so I can say map.put Mercedes comma 2, or I can say, so this would put a key Mercedes with value 2, or I can say map.remove Mercedes. So this would remove Mercedes from the list. And so this is put, this is remove, and the other one I can do is map.get Mercedes. It would return the number of Mercedes cars that are present, and earlier we had 5. So if we looked at here, we put 2. So if I do a map.get Mercedes, it would return back a value 2. So you'd see that all the methods which are present in here are to do with a key value pair. So I can put for a particular key a particular value, or I can get the value of a particular key, or remove a particular key. So it removes that particular key and value pair from the list. Or you can put all. So put all would actually take a list of key value pairs and put them all into the list. Also, clear is a standard method in most of the collection interfaces. It would remove all the values, key value pairs from the interface. The other important method is the key set. Key set, when I do the key set method call, it would return all the keys in the form of a set. So for example, if I did in the previous example that we had BMW, Mercedes and 2, if I do a key set on this particular thing, then I would get BMW, Mercedes and another. So that's basically what I would get back. So I would get the unique keys that are present inside the particular thing. And also there are other methods. Equals and hash code are the standard methods in Java classes. So that's standard. And also you can get the size of the map and also check whether it's empty. These are also standard collection methods. Contains key checks whether a particular key is existing on there. So for example, if I do a map.contains key Mercedes here, it would return back true. But if I do a map.contains key let's say Maruti, then I would get back a value false. And contains value checks for the value. So contains value 3 would return false. Contains value 4 would return me a value true. So those are the important methods which are present in the map interface. So we looked at the important methods which are present in the map interface. If you want to simply remember generically, a map is for key values pairs. So it provides all methods to put a key value pair. So it would be map.put key comma value, and it would have all the methods to retrieve values based on the key. So it would have get a value based on the key, remove a particular key, and also add all a list of key value pairs or a map of key value pairs. And also it has methods to check whether a key exists, whether a value exists, whether the list is empty, and also find out the size of the list. So having looked at the map interface, we will now look at the implementations of the map interface. So what are the implementations of the map interface? The most important implementations of the map interface are 4 classes. So it's hash map, hash table, linked hash map, and tree map. So it's hash map, hash table, linked hash map, and tree map. So what is the how these 4 classes are differentiated is based on something called sorting, whether the elements are sorted, whether the keys are sorted, or and also whether they are ordered. What I mean by ordered is the order of insertion. So if I'm inserting this set of key values where, so let's say I'm putting a comma with a value 1, I'm putting b or some x with value 2, and I'm inserting key b with value 3. So let's say I inserted these values inside the hash map. So if I do a map.put these 3 values, if these values are sorted by the key, then this is the sorry, let's get back to where we were. If these values are sorted by key, then this is how they should be stored. So first should be a, then b, and then x. Let's say I'm inserting in this order. So I'm inserting in the order, first I'm inserting a, then x, then b. If it's an ordered collection, then it should also store in this order. So the element which is inserted first is a, and then second is second, third is third. If the collection doesn't guarantee this, so if let's say I inserted it in the order of this, let's say I inserted after this y. So if I inserted it in this order, but the collection stores in some different order, then this is called an unordered collection. So in this collection, the order doesn't really matter. So there are collections where the order doesn't really matter. So for example, if all that I'm worried about is what is the value of b, then I don't really care about the order of this. I mean, I don't care whether b is before a or after a. Those kind of collections are called unordered collections. So these are unordered collections. And also, based on the sorting, so here a should come first, b should come next, x should come next, and y next after that. If you don't care about that, that's called unsorted. So unsorted and unordered. So hash map is a map which is unordered and unsorted. So it doesn't care about the order, it doesn't care about the sorting. So you insert in one order, it stores some other order and some other and not even in the sorted order. So that's basically what hash map is. Hash table, the most important thing about hash table is it's a synchronized version of hash map. Why is it important? If I'm writing a multi-threaded program, then it's very important that it's synchronized. If it's not synchronized, then the value which is changed by one thread might be overwritten by another thread. The last value might not be stored, and those kind of problems come in. So hash table is hash map plus synchronization. The other two implementations of the maps are linked hash map. Linked hash map is one where the elements are stored in the sorted order. So if I'm are stored in the insertion order. So I'm inserting z comma 5 and y comma 6 and let's say a comma 15. So the elements would be stored exactly in this order. So first z would be stored, then y, and then a. However, these are not sorted. So actually a should come first, y next, and z next if it's sorted. But linked hash map stores it in the order of insertion. So its insertion order is maintained, but it's the most important thing is it's also not sorted. So only the insertion order is maintained, not sorted order. The other important thing about any linked thing, I mean, anywhere you see a word linked, it means the elements are linked towards linked with a forward link and a backward link. And whenever there are links, insertion and deletion are very in this particular thing. Insertion and deletion are slow, but the iteration of elements is faster. The other type of map is a tree map. The tree map is actually sorted. So if I insert z, y, and a, then the order in which they would be stored are first A, it's sorted in the order of keys. So what would happen is it would be stored in this order. So A first, Y next, Z next. So that's a tree map. In tree map, the elements are stored in the sorted order of the keys. So the insertion order is not maintained. So those are the those are the 4 important implementations of maps. So if you want to remember easily, then you can remember this way. A tree map maintains sorted order. So it maintains elements in the order of sorting. So A, Y, Z. A linked hash map maintains it in the order of insertion. So if it's inserted in this order, then it would maintain Z, Y, and A. A hash map neither maintains a sorted order nor maintains the insertion order. So it just stores it in some random order which is decided by the algorithm. So there you go. Those are the important things about the map interface, and those are the important classes inside the map interface. Until next time, bye.
If you like this video, show it by clicking like or commenting or sharing this video. We are creating more videos on varied range of topics as we speak. Subscribe to stay updated. Thanks for watching. Until next time, bye.